Good morning, grade 10s. I'm here to do another YouTube video that will help you with the assignment that's due later this weekend. It's going to be, I'm going to give you some help on the section 2, part B, where you're graphing linear relations. And I'm going to help you with the question about the word problem, where you have to make two lines for two runners. One is running faster, one is running slower, and one gets to start ahead because that runner's slower. So I've made an example about my husband and me running a race, and so we're gonna look at that now together. Okay, so here's my question. It says, I run 0.25 kilometers every minute. My husband is slower. He only runs 0.15 kilometers every minute. So I'm gonna give him a 5-kilometer head start. So what I'm gonna do, so I better understand the question, is I'm gonna make a table of values for me and a table of values for my husband. And we're gonna look at a few things. We're gonna look at the equations that go with these two runners, my husband and me, and we're gonna look at the graph, and we're gonna maybe look to see when the two runners end up at the same spot in the race. Okay, so I'm gonna first make a table of values for myself from Ms. Thungraj. So time always comes first. So here, these are the minutes, and these are the kilometers. And it says that I run 0.25 every minute. That means in 1 minute, I run 0.25 kilometers. That means if I run another minute, I'll run another 0.25 kilometers. That means I'll run 0.5 kilometers. And then 0.75. And then after 4 minutes, I ran 1 kilometer. Okay, so we understand that. But remember, we're making a table of values for the purpose of making an equation, so we always need to start at 0. So if my pattern is I'm jumping by 0.25s, I'm jumping up 0.25 here. I need to jump back 0.25 when I'm going up in the table, or backwards in the table. So I need to go 0.25 minus 0.5, which means at the beginning, I would be at kilometer 0. That makes sense. Okay, so now let's make a table for my husband. Okay, it says I give him a head start of 5 kilometers. That means when minutes are 0, right at the beginning, I'm letting him start at kilometer 5. Okay, and then every 1 minute, he runs 0.15 kilometers. So 5.15 to 5.30, 3, 5.45, 4, 5.60. And so what we want to do is we want to figure out when the two tables will be the same. Okay, so let's do a couple things. Let's first create an equation for Ms. Thungraj. So here, these are kilometers, these are minutes. So my kilometers, at the beginning, they start at 0 and they jump up 0.25 every minute. If the y-intercept or the initial value is 0, you don't need to really write it down. You can just write down kilometers is equal to 0.25 every minute. Okay. For Mr. Thungraj, I have K and M. His kilometers, they start at 5 and they go up 0.15 every minute. So I've got two equations. I want to figure out when they are the same. Now, there are two things you could do. You could extend your table of values, keep going until they're both the same. But that would take a really, really long time. So what we want to do is we want to show with algebra that we can figure out when they are the same. So I'm going to put both equations next to each other. 0.25 every minute, that's Ms. Thungraj. I want to know when that's the same as 5 plus 0.15 every minute. I want to know when those two equations are the same. Okay, so what I need to do is I've got two different things going on here. I've got y-intercepts and I've got slopes. Here, this is a slope. So what I want to do is I want to put my two parts with the slope together on the same side of the equation. So here I have a slope, Here I have the slope. I want to move both slopes together. So what I'm going to do is I'm going to move it from this side and move it over here. Okay. So I'm going to go 0.15 minus 0.15. This cancels out. Here I just have 5. And here I have 0.10 m. Okay. So I now want to figure out what do I do now if I want to find out when they will be the same. Okay, so what I'm going to do is I want to get the m by itself. So I'm going to divide this side by 0.10. I'm going to divide this side by 0.10. And that means that the minutes will be the same at 50 minutes. That means if I were to make both of these tables of values go down to 50 and make this table of values go down to 50, the number here and the number here would be the same. They should be identical. After me and Mr. Thungaraj have ran for 50 minutes, they should be the same. So let's see what that means. That means here, my kilometers would be 0.25 times my minutes are 50. So 0.25 times 50. What's that going to be? Hey Siri, what's 0.25 times 50? Okay, so Siri gave me the answer. 0.25 times 50 is 12.5. So when the kilometers are 12.5, we've both ran for 50 minutes, so that's when we should be the same. Let's check to make sure we didn't make a mistake. The way we can check that is by trying the other equation. So I'm going to use my husband's equation. His kilometers, they start at 5. They go up 0.15. The minutes are times 50. If I go 5 plus 0.15 times 50. 0.15 times 50, I believe, is 7.5. 5 plus 7.5 is equal to 12.5. So that means after 50 minutes, Mr. T and Mrs. T will both be at the 12.5 kilometer point in the race. Okay, I hope that video helps a little bit. If you have any questions about the assignment that's due on the weekend, please send them my way and I'll make some more YouTube videos to help you. Thanks.